Here are the solutions to chapter 26. We wanted to simplify negative 5 square minus negative 5 square in parentheses, minus the absolute value of negative 5 square, minus the quantity negative 5 cubed. Well, what can we do? Exponents first. All this is my p. There's no group that holds things together because every set of parentheses or absolute values has only one number. Exponents. 5 squared is 25. The 2 is only over the 5. Negative 5 times negative 5. The exponent is over parentheses, is 25. Absolute value of negative 5 is 5. Square again is, 25. And negative 5 cubed. Negative 5 times negative 5 times negative 5 is negative 125. So I am adding 3 times 25, that's 75, negative 75, plus positive 125, or 50. So the answer to the first problem is 50. Can I go on? What is your position on the number line if the pair of dice is thrown 4 times and the numbers are 2 and 3? The way I made it up, if you have an odd number that's a negative, so negative 1, negative 5, and you multiply the 2, so that's a positive number, you move forward 5 steps. You move backwards you move forward 5 steps. A negative number times a negative number is a positive number. 4 times 6 is 24, positive 24. You go forward another 24 steps. Oh, I have another one here, the 2, 3, I missed that. Positive 2 times negative 3 gives you 6 steps backward. Positive 5 steps forward, so negative 6 back, 5 forward. And then 4 times 6, 24 steps forward. And finally, 4 times negative 3, negative 12 steps backward. Final position, negative 6 plus 5 plus 24 minus 12, 29 minus 18. This 29, 2 positive numbers. I'm adding the 2 negative numbers. Positive plus negative is, in this case, a positive number because you have $29 in the bank. You take out only $18, you still have something in the bank. You have $18 in the bank. So you are at 11 steps forward of where you started out. Okay, I'll leave this up for a few seconds. Interesting little game. Play it with somebody who is just learning numbers, maybe number multiplication and positive and negative numbers. I bet you small children would be pretty good at that, better than their parents. What happened? Did something move here? Excuse me. So I don't know what moved. If I go back up here, this we did earlier. We just did this part here, and I think you can figure out what's here. I talked about it, so that should be okay. Now in the third problem, there's nothing else. This is all there is. Okay, I'll do the next one. So we are in the next chapter, which is chapter 27, exercise to chapter 27. Divide 24 by negative 2, you get negative 12. Pick x, which is negative 11, and u is a sum of 11 and 5. So u is the sum of u negative 11 and 5. Why is that? Oh, that's negative 11. That's the number you pick. So negative 11 plus 5, negative 6. Then you get twice this number, and you subtract 3 from it. That's negative 25. P is the product of negative 25 and negative 6, so positive 150. Y is the previous P minus what? P is the product of U and V. P is the product of U and V. And Y is the difference between P and 2x cubed. The difference between P, which is 150, and 2 times x cubed. 2 times, where was x? Negative 11. Negative 11 squared, 121, so 242. Difference, you subtract. Negative 92. Z, you add 15 to the previous y, and your final answer is you divide this number by 7 and you come out with your original negative 11. Isn't it interesting that you get your original number back? When you worked with the numbers you picked, did you get the number back that you started with? You should have. If not, go back and redo it. Divide negative 24 by 2, that's negative 12, because 2 times negative 12 is negative 24. Divide negative 24 by negative 2, that's positive 12. Again, negative 2 times 12 is negative 24. Divide negative 5 by 0. Oh. Divide by 0. What did we say about dividing by 0? That's a no-no. The result is undefined. You cannot divide by 0. There's no number that you can multiply. There's no number here that you multiply by 0 to get the quotient negative 5. 0 times any number is always 0. And that's it for those solutions. This is chapter 28. And we have an introduction to basic statistics. I tell you, every chapter in my book here is a section in Art's book, and we want an introduction to basic statistics, and then tables and graphs. The science that deals with the collection, classification, analysis, and interpretation of numerical facts or data, like population trends or great distribution, is statistics. Okay? So we got data, and we want to maybe not manipulate data, but rearrange data and make it in such a way that maybe we can predict a trend or something. One such statistics is the mean, called the arithmetic mean, which is the ratio of the sum of n numbers and n. Ratio means fraction. You have the sum of n. You have the sum of all numbers in the numerator and how many numbers you added in the denominator. The median of a road is a line painted or imagined painted in the middle of a road. Imagine a two-way highway. You have traffic going one way and traffic coming the other way, and they are on opposite sides of the median of the painted line. In math, the middlemost of a number, the middlemost of a collection of numbers is the mean. The median, not the mean. So, just like on the road, you have the middlemost number. So a number that occurs most frequently, that's something else, that's called the mode. For instance, if you had a bunch of numbers, 1, 2, 2, 3, 2 occurs more frequently than any other number, 2 is the mode. Okay? Mode, most frequent number. Median, middlemost number. Mean, or arithmetic average, the sum of the numbers divided by how many numbers. There are two modes in some numbers, like a bunch of numbers right here. So you have 2, which occurs twice, 4, which occurs twice, no other number that occurs twice. So you say you have two modes. 2 is a mode, and 4 is a mode. If there are 3 numbers that occur most frequently and the same number of times, like 2 2s, 2 4s, and 2 6s, then you say you don't have a mode. Mode exists if there's one set of numbers or 2 sets of numbers that occur more frequently than the others. And when you have 2 modes, it's the same number in both modes. As many as you have in one set of modes, you have in the other set for the mode. The range is the spread of the data, namely the smallest number subtracted from the largest number. If you went from here to here, this would be the range right here. The following reference is for your edification and enjoyment. It is a short booklet. It has about 100 pages. There's large print. It is easily understandable. It's written for the 8th grade with a lot of illustrations. The purpose is not to teach you how to lie, but to make you aware of how people use statistics and omissions of data to fool you into reading between the lines. It's quite an eye-opener. It's very enjoyable. It's a little book. I'll give you the title shortly. It's very enjoyable. It's amusing, and it has a lot of information. If you can get a hold of that book, oh, you're going to love it. The book is How to Lie with Statistics in Paperback by Darrell Huff, Darrellhuff. So How to Lie with Statistics. And the international standard book number, the ISBN, is 9780140136296. 978014013696. Here is what one reviewer said. Darrell Huff runs the gamut of every popularly used type of statistics, probes such things as the sample study, the tabulation method, the interview technique, or the way results are derived from the figures, and points out the countless number of dodges which are used to fool rather than to inform. Okay? So statistics, the way statistics is presented or not presented, some things are left off, may try to lead you to believe that something is when it is not. Like, and I probably have that somewhere, you have a picture. So you have two axes. You have the vertical axis and the horizontal axis. And you have a stock. You have the years down below, the year 1980, 1990, 2000, 2010, 2014. And you have stock price, the value of a particular stock vertically. And without putting numbers over here, the line goes up very, very quickly, very sharply. That leads you to believe that look how the stock rose over the years. I have to buy that stock because I want to be in on it. But now if you put numbers down, this is $10 and this is $10.10. So over about 40 years, it gained 40 cents. Would you still buy that stock? I'm sure the answer is no. Inflation would eat up more than the 10 cents that you gained. Examples. My new car recorded the following miles and gallons of gas in a 2-month period. Find the average rate of miles per gallon. Okay? Miles per gallon. Miles on top divided by gallons on the bottom. You have a fraction bar. Round to the nearest tenth. So you have miles, you have gallons. 221 miles, 8.5 gallons. 245 miles, 9.8 gallons. 294 miles, 10.5 gallons. So you wanted the mean, the average, the mean of miles per gallons. Okay? So miles per gallon, we divided 2, we get 26 miles per gallon. 245 over 9.8, 25 miles per gallon. 294 divided by 10.8, 28 gallons. The average, the mean, is the sum of these three numbers divided by 3, which is somewhere around 26, 27, just looking at these numbers. Okay, 26 plus 25 plus 28 divided by 3, 79 divided by 3, about 26.3 miles per gallon. Miles on top per gallon on the bottom. Again, the units are very user-friendly. Make use of units. Miles per gallon. Okay, we have another type of problem. Suppose your grades on the test were as follows. 75, 88, 86. What grade must you score on the fourth test so that your average is at least 80 points? What is the average? You have the sum of the four numbers. What is your fourth grade? Well, put it in a box with a question mark. Although lots of people would say X. Instead of X, I have a box with a question mark. Replace it by X if you want to. So the average is 75 plus 88 plus 86 plus the number we are after divided by 4. 1, 2, 3, 4 numbers, which is 80 or more. So at least 80. Add these three numbers, you're supposed to get 249. 249 plus some unknown number is 80. Multiply both sides by 4. This 4 drops out, and this 80 is multiplied by 4. So you get 249 plus, call it X, is 320. Subtract 249 from both sides. You get X, which is 71. So you must score at least 71 points in order to get an average of 80. Could you get an average of 90? That's a very interesting question. If you have 90 here, that would be 960. 960 minus 244. Oh, that's over 100. Too bad you didn't score a little bit higher earlier. The 90 is out of the question. Sorry about that. So as I said, you must score at least 71 points on test number 4 for your average of all the tests to be at least 80. The monthly rainfall in Ames, Iowa is January, February, and so on through December. You want to make a quick box and take those numbers down. So January, February, March, April, May, June, July, August, September, October, November, December. And once you have that, in January, 0.75. In February, 0.87. 0.87. In March, 2.05. March, 2.05. April, 3.5. May, 4.33. June, 5. July, 4.45. August, 4.33. September, 3.07. October, 2.68. November, 1.97. December, 1.06. So 0.75, 0.87, 2.05, 3.5, 4.33, 5, 4.45, 4.33, 3.07, 2.68, 1.97, 1.06. The median monthly rainfall, then we have to rearrange the data from smallest number to largest number. And when I did that, I came up with 0.75, followed by 0.87, 1.06, 1.97, 2.05, 2.68, 3.07, 3.5, 4.33, 4.33 again, that probably qualifies as the mode, 4.45, and 5. The median of the 12 numbers is the average of 2.68 and 3.07. There is no middlemost number, but there are two numbers which are exactly in the middle, these two. So here we say the median is the average of the two middlemost numbers. The median of the 12 numbers is the average of these two, which gives you about 2.88. So the median rainfall in Ames, Iowa over that particular year was 2.88 inches per month. If the number of items were odd, then the middlemost number would be the one of the listed numbers. We would not have to take an average of two middlemost numbers. If December was omitted, so if the 5 here is omitted, then we have 2.68, which is exactly in the middle. So for 2.68, we have 1, 2, 3, 4, 5 numbers below, 1, 2, 3, 4, 5 numbers above. The 5 is not there. Okay? So that's the median, the middlemost number. Okay, I just said that. And then we wanted to find the mode in the following set of data. 6, 9, a number, a second number, both unknown, and 12. If the mode is 10, what are these two numbers? Can you figure that out? Well, if the mode is 10, 10 must occur most frequently, so this has to be 10 and that has to be 10. Mode is the number, if there is such a number, that occurs most frequently, more often than any other number. So both numbers must be 10. Okay. what is the range of the rainfall in the rainfall example above? We rearrange the numbers from smallest to largest. You have already done that. The range is the largest number minus the smallest number, 5 minus 0.75, or 4.25 inches of rain over the entire year. So you go from smallest number to largest number. Is that useful? Yeah, you know how large a scale to make. Oh, then we get into exercises. And exercises means what I want you to do. And then I'll give you the solutions next week. So, my new car recorded the following miles and gallons of gas in a 2-month period. Find the average rate of miles per gallon. Okay? And round to the nearest tenth. So the data is 306 miles, and I consumed 8.5 gallons. 336 miles, and I consumed 9.6 gallons. 378 miles, and I consumed 10.5 miles. Okay? So we wanted the average or the mean rate of miles per gallon. Remember, miles per gallon. Then we were interested in your grades on 3 tests were as follows: 95, 88, and 76. What grade must you score on the 4th test for the average to be at least 80 points? Seems to me that maybe you could even make 90 points average. Well, you take a look and try it. If I do something quick, that's about 100 plus 90, 190, and 70, 260. 260 divided by 3. Yeah, I think you can still make it. It's a borderline case. And you figure out, I asked you for 80. Also check if maybe you can get 90 points average. Maybe. And if your instructor goes by the scale, 90 or above is an A, 80 to 90 is a B, maybe you can get an A. Extra credit, anybody? You don't have work enough? You need to ask for extra credit? Okay. Then we have rainfall in a city. And you go ahead and copy these numbers. Again, you have January, February, March, April, May, June, July, August, September, October, November, December. I'm going to go out for a cup of coffee. You call me when you're ready. You saw the shadow, you know I'm still here. I just don't want to get in the way of you copying these numbers. Okay, should I go on? We have the mode problem again. We are given 5 numbers, 2 of which are unknown. We want the mode to be 30. So what do those 2 missing numbers have to be? We have 2, 9, x, y, and 200. I'll call the first question mark X, the double question mark Y. That's the letter Y. And then we wanted to find the range of the rainfall in the example we just had, in example 3. So if you have this in order, you can find out what the range is. And again, as I said, I'll let you copy. Maybe I'll show you the answers, just the answers, not how to get to them. I got an answer of 35.7 gallons. I got an answer of 61 points. I've got an answer of 4.77. That was a median rainfall, 4.77. And then the mode was 30, and the range was 4.93. As I said, I just wanted you to get the answers without showing you how to do it yet. And I think I succeeded. Chapter 29, tables and graphs. This corresponds to, oh, why doesn't that work? Okay. A table is a means of arranging data in rows and columns. Rows this way, columns that way. The use of tables is pervasive throughout all communication, research, data analysis, and so on and so on. I got that from somewhere. I'll give you the source. Tables appear in print media, handwritten notes, computer software, architectural ornamentation, traffic signs, and many other places. If you're interested in more detail, go to this place on the computer. Okay? You don't have to copy it if you have my PDF. Otherwise, you have http://en.wikipedia.org wikipedia.org/wiki $table_$28 information $%. Did I say $% here? And 29. Some examples. I got this data from the IRS, an IRS publication in the year 2013. Here's a table. You have one top row 1, 2, 3, 4, 5, 6 rows down here. That's the end of the rows. You have the columns. This is the calendar year, 2012, 2011, 2010. You have the wage limit. In 2012, you got tax, Social Security up to an amount of $110,100 of income at the rate of 10.4%, whereas in the same year, Medicare went over all ages, no limit, at 2.9%. In the next year, Social Security, the limit was $106,800 at 10.4% again. Medicare, all wages at 2.9%, like previously. In the year 2010, Social Security, the limit was $106,800, like the previous year. And the rate was 12.4%, whereas Medicare did not change. All wages, 2.9%. You may want to copy this quickly. So you have the calendar year, 2012 twice, 2011 twice, 2010 twice, Social Security and Medicare in all 3 of those years. Medicare all wages, Social Security limit for 2012, $110,100. In 2011, $106,800. And the same for 2010, $106,800. Percentage. For Medicare, 2.9% in all 3 years. For Social Security, 10.4%, and again 10.4%, and then 12.4%. Now the question, making use of that table, find how much money is withheld for Social Security for a person earning $20,000 in the year 2010, and then a person earning $20,000 in the year 2011, and a person earning $200,000 in the year 2010 now in C. So in A it was 20,000, in B it was 200,000. In D, it is earning 200,000 in Social Security in the year 2011. So it's again 200,000. And then 200,000 in the year 2012. So you figure that out. The wages are 20,000 in 10, 20,000 in 11, 200,000 in 10, 200,000 in 11, 200,000 in 12. Solution. What is, remember when we worked with the percent, amount is percent of base. So taxes owed, 0.124, I should probably say 124,000, multiplied by 20,000, I came out with $2,480. You may agree or disagree. What is 10.4% of 20,000? 2,080. What is 12.4% of 106,000? That was the limit. Well, 0.124 times 106,000, I came out with $13,144. Is that approximately right? About 1/10 of this is 10,000. So a little bit more than 10,000. That's probably right. It's a ballpoint figure. How about 10.4% of 106,000? I came out with 0.104 times 106,000 or $11,024. You want to copy that for a few seconds. And then we have a part E. 10.4% of 110,000. I came out with 11,440. Okay, we move on. That was tables. Here's an example of a pictograph. Assume these are apples. I couldn't draw an apple, so I just drew a circle. And each circle, each apple is worth 10 pounds. How many red delicious apples do we have in the store? 10, 20, 30, 40, 50, 55 pounds. How about golden delicious? 10 pounds. Red Rome, 10, 20, 25 pounds. Macintosh, 10, 20, 30, 40 pounds. And Jonathan, 10, 20, 30, 40, 50 pounds. I'm giving you the numbers below. And you can also represent those numbers so there are 25 pounds of red apples in the store. The same information can be given by a bar graph. These are bars, and this may go a little too high for viewing. The first column A signifies red delicious, the second column B, golden delicious, the third column C, red Rome, the fourth column D, Macintosh, and the fifth column E, Jonathan. And on the side you see 10 pounds, 20 pounds, 30 pounds, 40, 50 pounds. A was 55 pounds, B was about 10 pounds, C was something like 35 pounds, D was something like 40 pounds, and E was something like 50 pounds, just like the information we had in the pictograph. So pictograph and bar chart, same information, just presented differently. And at one quick look, what do you have most, what do you have least? Most here, least right here. That's the advantage of bar charts or pictographs or analysis of data. At one glance, you can get information to make a decision from. And then we have a histogram, which looks like a bar chart. And this came from the city of Los Angeles with the census in 1990. The age group was 62 to 64. How many people did we have in the city? 2.11%. The next group, 65 to 69, 114,701, 3.29%. I don't know if you want to copy this or not for reference, which we'll need later. 70 to 74, I call that C, 88,622 or 2.54%. It would be so much easier if you had the PDFs. 75 to 79, 66,815, 1.92%. 80 to 84, 41,532, 1.19%. 85 or older, 34,293, or almost 1%. So if you're copying, I let you copy. Representing this as like a bar chart. I don't know if you copied the numbers, but assume this is correct. And then the question is approximately how many people? 70 to 75. 70 to 75, this column. This column, where does this end? Just under 90,000. 89,000, 88,000. Two different people can get two different answers, but very close, okay? Again, you can look at this quickly. What was the biggest population? Over 110,000 of people 65 to 69. The least 85 and over. Okay, so at a quick glance you can get information. There are about 60,000 people aged 75 to 79. About. That's the best you can do. It won't be exact. And then a line graph. We are back to the apples. Remember the bar chart ended here, the bar chart ended here, then here, then here, then here. At the top of the bar, put circles, remove the bars, connect the circles with lines. Okay. What did you have? Most apples? Here, here. Least apples right here, and these two in the middle. How many apples of Red Delicious did you have? Red Delicious was B, and B was about 10. Okay, they're about 55. Red Delicious, 55. Oh, I'm sorry, Red Delicious is A. A is 55. What did I say? Golden Delicious? Golden Delicious was supposed to be 10, and we're not asked about Golden Delicious. Now, a circle graph or pie chart. You have 541,000 personnel in the Army, 195,000 in the Marine Corps, 317,000 in the Navy, 334,000 in the Air Force, 42,000 in the Coast Guard. If you add all these up, you're supposed to get 1,429,995 personnel in the armed forces. If you convert that to a percent, what does 541,000 of 1,429,995? Apparently 37.9%. Then here are the percentages. They should add up to 100. They may or may not. You may be a little bit off because these numbers are rounded numbers. So if you get 99.8, 99.9, or 100.1, 100.2, that's okay. Now convert the percentage to degrees. We have a total pie chart, 360 degrees. The Army represents 37.9% of 360, 136 degrees. The Marine Corps, 13.6% times 360, about 50, and then 80, 84, and 10, and the total is 360 like it's supposed to be. Put this information on a bar chart. So the biggest piece is going to be the Army, and the smallest piece is going to be the Coast Guard. The Army is the biggest piece, the Coast Guard is the smallest piece, the Marine this way, the Navy this way, the Air Force that way. At a quick glance, we see which pie is the biggest, which is the smallest, which is in between, approximately how much of the total. Almost half of the total right here. And then the Army and the Marines together will have as much personnel as the Navy, the Air Force, and the Marine and the Coast Guard all together. Now I am asking you to do exercises. You have the same Social Security information that I gave you earlier. You want to find out how much money is held for Medicare when you earn $20,000, and what is 2.9% of 200,000? And then how many pounds of Macintosh do you have? The same information that you had previously. So no need to let you copy this unless you didn't get it earlier. And then you have apples, oranges, bananas, pears, and grapes. And how many of these do you have? How many pounds of oranges do you have? Oranges, I think I kept the chart the same, the bar graphs the same. I just changed the names. Instead of apples, I have apples and oranges, bananas, pears, and grapes. So how many oranges were there in the store? And then finally, the city of Los Angeles, the same histogram that we had previously. Approximately how many people are 85 or over? Well, what is that number? What is that number? I'm still in the picture. Okay. Okay. We have the same information we had previously on the line graph. How many apples, how many Jonathan apples are there? And then we have an entire pie. If the entire circle represents 100,000 people, approximately how many are in the, just one D, P or Q slices? Or means and. Oh, I want to stop and I want you to do it. So P or Q together.